would be -2, and the y-coordinate would be f of -2. This point over here would be 4, and the y-coordinate would be f of 4. And based on the scale here, this would probably end up being about 0, comma f of 0. This would be about 2, comma f of 2. So I really don't know that f looks like this, but just pretend for a minute.
Should we be drawing it like that?
Yeah, just draw that in your notes. The drawing that I have on the board will be sufficient to illustrate the idea I want you to make sense of. One more caution today. Don't copy what I do. Make sense of what tools we're using, because you have to use the tools to answer the 15 questions in the yellow. You can't just do what I do on one problem on the other problems. You've got to use the tools. Maya?
For the minimum and maximum, why is the x-coordinate 0 and 2?
For these
Where
two.
those numbers come from?
Totally random. I just said, hey, not knowing what f looks like, if f happened to look like this, that's all. So I don't really know what f looks like. 2 points? Anyone else? Hey, raise your hand if you can tell me if f actually did look like that. Raise your hand if you know where f would have its absolute maximum value. If f really does look like that, hands up, where would f have f's absolute maximum value? Don't overthink it. Talk to each other. Raise your hand if you can tell me if the graph of f actually does look like this, where would f have f's absolute maximum value? Drew? How many agree with -2? 2 points. Simple. Any questions? Raise your hand and tell me where would f have f's absolute minimum value? Where would f have f's absolute minimum value? Noah?
4.
So at x equal 4, how many agree? 2 points. Anyone have a question? Please tell me where would f have a relative minimum? Boston?
X equals 0.
How many agree? 2 more. Where would f have a relative maximum? James?
X equals 2.
How many agree? 2 points, just giving them away. Put down 2 more just to aggregate. So, seriously, 2 more. Okay. Any questions about what is meant by absolute max versus relative min versus absolute min? You should remember from Unit 1 that the words they'll use are, if they mean relative min, relative max, or relative extrema, they will always use the word either relative or local. You must memorize that. So if they mean relative extrema, relative min, relative max, they'll always use the word either relative or local. Okay, question? If they mean absolute max or absolute min, they don't always use the word absolute. Everybody hear that? If they mean absolute max or absolute min, they don't always use the word absolute. They just say max. And they just say min. They'll do it both ways.
Is it the same as a global maximum?
It is exactly the same thing, although I've never seen them use the word global on the AP test. But it is the same thing. 2 for Rachel, 2 for Dan. Everybody clear on the ideas? Awesome. Okay, so we don't know that f looks like this, so we're going to erase this. Well, you're going to keep in your notes, but I'll erase this. We need to get a graph of f. If we have a graph of f, we can answer this question. So the method I'm going to teach you for graphing f is a lot easier than the methods you learned in other classes.
Will this part, or this question be on the section where you can use your calculator? Okay.
Yeah, with the calculator we do this in a different way. It's perfect. Okay, here we go. So step number 1 is we're actually going to graph f by using f prime. So keep it straight. We're not graphing f prime. We're graphing f. But we're going to graph f using f prime. So let's take a derivative. So f prime equals 3x squared minus 6x. So that you need to memorize. We are graphing f itself using f prime. Next thing you must memorize. You must have f prime in factored form. This method I'm going to teach you will not work if f prime is not factored. So, I guess an exception to that would be we could try and use the method thinking of this as one big factor. That does work, but it's harder. So the more factored f prime is, the easier this method works. So pull out a 3x. That leaves x subtract 2. So now f prime is factored. I think of f prime as being 2 factors. 3x multiplied by x minus 2. The method won't work if you try to do it with these 2 terms. One more time. If you try to do this method using these 2 terms, you will fail. Okay? You must use these 2 factors. You need me to repeat that. Awesome. Okay, next step in the method is if we're going to draw a graph, we need an x-axis. So I draw an x-axis. Paying attention to the fact that I really only need x values from -2 to 4. So here's -2. Here's 4. Putting 0 about here. Okay, don't draw a tiny x-axis. If you do this in a tiny space, you'll make mistakes. Guaranteed. Get a little bit of space.
What's the x?
The more paper you use, the more intelligent you are. So, fact of life. Fair voice.
Never mind. The x after the 4 is just the axis. Not
Right, just labeling the axis. It's kind of in an awkward place. We should probably move that. 2 points for Brennan. Cool. All right, next thing. Please raise your hand. Okay, today, look, if it feels slow, I apologize, but this method involves several different ideas that you must have memorized and must make sense of. And if you don't, you won't be able to do any of the homework. So I'm going to just keep asking you for feedback to make sure you are truly following. Danny, please.
So, if you take the derivative and you can't factor anything out, do you just use that equation, or can you just not use the derivatives?
Perfect. So if I take the derivative and I can't factor it all, I must think of this as just one large factor.
Okay.
I still can't do it with terms. That wouldn't work. But I can use the method if I think of this as one large factor.
Okay.
That will work. And we'll see that in some future problems.
Okay.
Good question. 2 points. Anyone else? Please.
Can you solve this without doing,
This method.
this problem without doing all this code?
I would say there are other ways you can do it,
Because
but I
if you
actually...
think about it,
Go ahead. Talk to me.
well, if you know the graph of f is like positive, so it's going this direction, and it has to be the absolute maximum, and it has to be 4, doesn't it?
4 is the correct answer.
Yeah.
Oh my gosh,
You just let me do it. I don't follow.
why is it 4?
How do I say this?
She's cheating.
4 is correct. I can't deny that. 4 is correct. I wouldn't say that in general you're going to encounter a problem where you'll be able to see that. There are other methods for solving the problem. I personally find this one to be the easiest. It may feel complicated at first because I'm going real slow, but once you understand the idea, it's actually, in my opinion, the easiest way to do it.
But so if I do encounter a problem on the AC test and like you can figure it out like that, then like you don't have to do all the work.
You don't. I'd be cautious. It's easy for them to create a problem that will trick you. Like I could change this problem just a little bit and the value wouldn't be 4 any longer. So be a little careful with that. Anybody else? Do you have it? Awesome. Okay, next thing. Write down, hey,
I'm still.
list the factors here. So I'm going to put 3x and then x subtract 2. And note that those two factors multiply together and the result is f prime. So please put a label for f prime. You could put a multiplication symbol here. These two are really multiplying. I don't really like to do that. It looks like we're writing an x. But those two are multiplying. So. Questions?
Why is it f prime of x again?
So 2 points for Danny. What I'm indicating in this chart right here is that if I take this factor and I multiply it by this factor, the result of the multiplication is f prime.
Okay.
Anybody else? Awesome. Next thing. These are different values of x. One or more values of x will make this factor equal to 0. Don't think too hard, but raise your hand if you know what value of x will cause this factor to become 0. Just raise your hand. Don't think too hard here. Isaac?
0.
How many agree? Point. 2 for Isaac. So put a 0 right here. Okay, critical portion now. Critical. Okay, critical. I have seen many times in years past that people watch attentively as I do this, and they completely miss what's really happening. So I'm going to say to you what's happening, and then if it doesn't make sense, wave so we can talk some more. The way you read the chart, it's called a sign chart, is I say, okay, if the x value is 0, and that x value is plugged in here, this 3x would be equal to 0. That's how you read the chart. It's just like a table. But instead of writing the table vertically, we're writing the table horizontally. Otherwise, it's the same thing. Plug in an x, find the y. Please.
If you plugged in 2, would you also get number 0? Because of the...
So this one here, definitely, if I plugged in x equal 2, 2 subtract 2 would be 0. So I don't want to put a 0 here. That makes no sense, because that's referring to what 3x is doing.
Okay.
I do want to put a 0 here, because x minus 2 is going to equal 0 when the x value is 0. 2 points. That's how the chart is read. So this line in the chart only refers to 3x. This line in the chart only refers to x minus 2. You would need me to repeat something. Please.
One question, like, I get how it's the chart, but I just don't get how you know which number is going to like which equation. Do you know what I mean? 'Cause like, if you
it's
plug
like
0 into 0 minus 2, then it's not 0.
correct. So hold on
So
that
is that
thought.
why you have colors? Or?
You're good.
Okay.
So it's the organization of the row versus the column that's important.
Oh.
So that's why it's critical that you keep it organized. So when x is exactly 0, this row has a value of 0. When x is exactly 2, this row has a value of 0. Is that your question?
Yeah.
2 points. So
That's
now,
why it's like loading.
please.
Do you fill any of the values, or do you just do the 0?
Perfect. So the next step is we want to get something written here and we want to get something written here. Okay, so we can know what's happening for all x. The beauty of this method is you don't have to do any real computation. You only care about the signs, positive, negative, 0. So, and the other beauty is that for the problems we work in this class, once I know what's happening at one spot over here, it's the same for everything else. So it's like one computation answers a million different computations. For example, I need a volunteer. Boston. Pick a number, any number, it's like a magic trick. Pick a number. Anywhere between 0 and -2.
Oh, -3 then.
Anywhere between 0 and -2.
-point.
Why is a good question. What number would you all pick if I said pick a number between 0 and -2? Genius. 2 for y'all, 2 for Boston. So if I pick -1, look up, come on, look. It really doesn't matter which number you pick. But pick -1, plug it in for x, and just say it out loud, please.
See that?
And the important part is you actually do not need to find the number. You only need the sign, negative. Okay? If plugging in a -1 gives a result that's negative, I can guarantee you plugging in any of these other values will also give a negative result. So I don't have to do any other computations. They're all negative.
And you know that then it's not maximum.
What's that?
Then you know it's not maximum there.
You're heading in the right path. We just want to go a little further. So you're okay. 2 points. Is everybody good here? So the way you read the chart is, if x were equal to -1.9, this would have a value that is negative. If x were equal to -1.5, this would have a value that's negative. So I think you can guess what the next step is. Raise your hand if you can guess what's the next thing I'm going to do. Hands up. It's very logical once you get the feel for it. Please.
Look at a number between 0 and 2, or 0 and 4.
0 and 4. Pick any number between 0 and 4.
2.
2 is awesome. Plug in a 2 for x. What's the result? Positive. That means it does not matter what number I pick, the result for all of those numbers will be positive.
So is that until it reaches another 0 on that line?
Everybody listen to Elijah, please. Listen. That's why we pick the zeros first. Between the zeros for our class, it's never going to switch. Or sometimes you have an undefined and it can switch between the undefined. Please. 2 points. Anybody else? This one you can't. But it's not uncommon to do a problem where, listen close, where instead of having a factor that multiplies by a factor to produce the f prime, you have a factor divided by a factor. And dividing by 0 would produce an undefined. That's the most common. 2 points, please.
You're saying like unless we factor, like if we used 3x squared and -6x, then we'd like get the messed up. Okay.
The reason it would mess up is going to show up in a minute. So 2 points.
What if you don't have an x as one of your factors? And say it was just 3x and 3 or something like that.
Awesome. The next problem that's going to show up, we'll just wait on that one. I'll show you.
Okay.
2 points. Anybody else? Cool. Hands up. What's the next thing I do? You guys got the logic down now. Hands up. I want to see everybody because honestly, like if all you can do is watch me, the homework's a disaster. Test 3 is a failure. Life is bad. So, Rebecca.
So I did the same thing, but that's times 2.
Nice. So we just come here, Rebecca. Pick any number. I don't care.
0.
0 is my favorite. So if I take 0, Rebecca, plug it in here, what's the result?
Negative.
How many saw it? 0.2 for Rebecca. Therefore, I don't need to test all of the other x values. The results will be the same. Question? We test the other side. So like 3. Say it out loud. Positive or negative? Positive. You're doing a superb job. Please.
Is it always going to be positive on one side and negative on the
No,
other side?
not uncommon to be positive on one side and positive on the other. Or negative on one side and negative on the other. So it goes both ways.
Is it possible to switch between positive and negative without a 0 or whatever?
Genius. Not unless you have an undefined point. So if there's an undefined point or a 0, you'll see the switch. Without that, you won't see the switch.
Okay.
Anybody else? Perfect. Trying to think of one other thing. I suppose suppose with a piecewise function it maybe could happen. But I've actually never seen them ask you to use this method on a piecewise. So, 2 points. Anybody else? Awesome. Okay, say it out loud. How do the two factors combine to create f prime? They multiply. They times. Okay, they multiply. So that's the next step. Watch how I read the chart. Like, watch how I read the chart. Do not just mimic my hand motions. You can see me tense up because I've seen people do that. Like, well, I know what you do. You do this. I'm like, why? I don't know. Got to know the why. Key to this class in all college classes is the why. So, if x is -2, this factor is some negative number. We don't care about the numbers. This factor is another negative number. You multiply two negative numbers, the result is positive. So I know now that if x is -2, the f prime will be some positive number. I don't really care about the number, just being positive is all I care. Question? So over here, when x is -2, remember this is the x-axis, this factor will have a value that's some negative number. That's what I wrote there. You good now? Yeah. Points. Anybody else? Awesome. Do the zeros first, though it's easier. Keep things lined up. A 0 multiplied by a negative is 0. So when x has a 0 value, this factor is equal to 0. This factor is negative. When they multiply together, f prime will be precisely 0. Please.
You could do this thing with like multiple things multiplied by each other, right?
Mm-hmm.
And you would just do the same thing.
Correct. Yeah, there is no limit to how many factors you can have listed here. Now, for our class, I haven't seen worse than like 4.
That's okay.
But there is no limit how many you could have. The technique doesn't change. So, please.
So how would you know when you use this technique? Like this strategy?
Gotcha.
You just
Hey, listen to Danny's question. If they're asking me to find the absolute maximum of f, I'll make a list for you. Absolute max, absolute min, relative max, relative min, local max, local min, relative extrema, local extrema. When is f increasing? When is f decreasing? When is f concave up? When is f concave down? Where are the inflection points on f? Any of those questions, if I don't have a calculator and they didn't give me a graph, this is the method. If I have a calculator, I never do a sign chart. If they give me a graph, I don't do a sign chart. But otherwise, I need the sign chart. I don't know an easier way.
What do we do in this step if we only have one factor?
Awesome. If there's only one factor, the method doesn't change. It's just that you're figuring out for f prime right away. Like you're just finding this line from the very beginning. The method is still the same. You still find out what's the x which causes f prime to equal 0. You still test on both sides of that x. So, yeah, we'll do an example of that next time. So, cool. Let's see. So if x is equal to 2, the 3x will be a positive number. The x subtract 2 will be 0. Those two will multiply, and my value of f prime will be 0. Question. Really, the concentration of the question is superb. You are right on track. Okay. Oh, please, Mikhail.
Could you do this with double f prime too?
We'll do that on the next one. It's perfect. 2 points. The method doesn't change. The method does not change. So now it's just this. Positive, negative, positive. Question. It's called a sign chart. So now I do this. If f prime has, for different x values, right? If f prime has these y values, these are y values of f prime. Everybody see? These are the y values of f prime. If I know this about f prime, I know this about f. Questions? Janica's chart.
Well, they're both y values, right?
These are the y values of f prime. They're positive, negative, 0. This is describing what the y values of f do. They go up, they go down. Perfect. Read the name for me.
Catherine Howard.
That was last period.
Pierce Chamber right now.
Sorry. I sent you to the wrong place. So, please.
So how would you
Sorry, here today.
how would you know if it was 4 and -2? Or like the answer because like the point where it switches from positive to negative is 0 and 2, so it's like equal distance. Am I making sense at all?
I think so. Let me say something back to you, see if it helps. The spacing for everybody, hey, this horizontal spacing doesn't mean anything.
Okay.
So even though it appears somewhat symmetric, that's not going to really matter. The symmetry doesn't give me any clues. So next thing I would do is this, though. I told you we were learning how to graph f, so now I graph f. Here's what f looks like. F starts, as far as we're concerned, at -2. I do not know the y-coordinate, so I just write f of -2. Then f is going to go up to here. That's at x equals 0. The y-coordinate's f of 0. Then f's going to go down. X equal 2. Y-coordinate unknown. F's going to go up. Question? So I can draw f. Second, Isaac, sorry. That's how I like to graph. Isaac?
Like, we know it's like increasing, but we don't know like how much, right?
Genius, 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 genius. So the method I'm using is quick, but it does not give all detail. Like I really don't know the curvature here. I really don't know if it's like a lot or a little. All I know is up. It's perfect.
So now, like, are the choices 0 or 4?
Genius as well. We're trying to find where f is highest. Okay, 2 for Brennan. He said, hey, the choices are 0 or 4, because of what Isaac said. You don't really know if this went up a lot or a little. You don't know if this goes up a lot or a little. But you do know that there are no higher points on f other than these two. These are the highest points that f can have. So one of these is the highest, the absolute max. You don't know which one. Okay? We need to explain why we know that 0 and 4 are the only two places where f can possibly be highest. Okay, don't speak out, just raise your hand. How do we figure out which one is highest? Show your hands. So one of those 2 points is highest on f, and you must know the method for finding which one is actually the highest. So what's the method for figuring out which one of those 2 is actually the highest? Weston?
You just plug in equation.
Which equation?
F prime. Or, I mean, you plug 4 into actually the normal. I thought just the slope. When you plug into the slope.
Into the slope? It's wrong, but watch, just make sure you can make sense why it's wrong. If I take x equals 0, right here, and I plug it into f prime, I already know the result, 0. Because this chart tells me that. And if I plug in 4 into f prime, actually that's interesting. It tells me that this is positive, but that's not going to tell me where f is highest. Like you're finding slopes. If you're working with f prime, you're finding slopes of f. So if I take x equals 0, the slope of f is 0. It's fine, it's flat. The slope here is positive, that's fine, but that doesn't tell me which one is actually higher.
So would you just plug it into F?
It's got to go into f. Does that make sense?
Yeah.
2 points for Weston. How many knew it? 2 points. One more caution on that. Hey, everybody, hey. No, Weston did a really good job, but listen. that's the kind of thing that I've seen go wrong in past years, is if you don't take the time to make sense of it like Weston did, you're just flying blind. You're like, well, I guess I plug it into F prime. So it doesn't make any sense.
So, seeing that you have these answers and you're just going to plug them into the original equation anyways, can you just do that at the beginning?
So nothing illegal about doing that. But here's how they'll prevent you from doing it. One way is they'll give you a question like this on the written section. So you can. The second way they prevent you from doing that is instead of saying, where does the maximum occur, they will ask, what is the maximum? Raise your hand if you know the difference. So this question says, where does the maximum occur? The way they prevent using that method that Noah described is they'll say, what is the maximum? So what's the difference between where is the maximum versus what is the maximum? Sarah? So where is the x? What is the y? Do you need me to repeat that? Okay, where is the x? What is the y? So Noah, if they say what is the max and they only list y coordinates, I have no clue which one is highest. I can't plug anything in. So, anybody else? Cool. So we go find them. So we go f of 0 is, let's see, 0 cubed plus 3 times 0 squared plus 12. So that's equal to 12. And we check f of 4. Let's see, 4 cubed minus. And free hint for the test. Test number 3 is going to take place about the first week in December. There's a problem on test 3 that if you understand this one, you're all set. But don't let the problem intimidate you because it's different. The method doesn't change. The key to doing well on tests in this class is, again, not thinking of problems, thinking of techniques, methods, rules, okay, concepts. Just apply them. So this is 3, 4 squared, subtract 12, sorry, plus 12. So this is going to equal 64 minus 48 plus 12, which is 16 plus 12. So f of 4 is 28. So the absolute max is at x equal 4, where the absolute max has a value of 28. Questions, please?
So is it just safer just to do this instead of even thinking about plugging it in case, like you?
Noah's answer is actually, it's very valid.
Because like
If
that
they
would-
just said where, you can just plug them in.
That would be way faster.
But I don't recall them doing that very often. This happened in 1988. Like, I think they learned their lesson and they never did it again.
So that you have to.
Yeah, so you have to do this.
So if the answers would have been like 12, whatever, blah blah, 28, then you wouldn't be able. You'd have to figure out.
Correct. And of course, the trap is people go, well, I guess it's the highest. No, just because the number up here is high doesn't mean that that's the absolute max of this function.
Oh.
See what I mean?
Yeah.
Like, they would have had
It could
answers
be-
like
it could,
this.
like just be some random.
They're like -2, 5, 28, 40, -10. And they'd say, you know, the absolute maximum value of the closed interval is like that.
And so people just choose 40, but it's like not even on the graph.
Correct. In fact, let's check the whole room. If they really did give you a problem, or they gave you a different function, so it's something else, and they said, where is the what is the absolute max? This is not meant to be a trick. I just want to make sure you're understanding. Raise your hand and tell me. This is kind of a trick question. I want to see if you know what I'm talking about. Which of these could not possibly be the answer if they said the absolute maximum value is? Raise your hand if you know what I'm talking about. I'm trying to trick you. So, which of those could not possibly be the answer? If they say which of these is the absolute max? Which of those could not possibly be the answer? Come Maya?
Is 40, knowing what we know now, or just going straight?
No, just going like a brand new problem. You're fine. So it's a brand new problem. They give you a new formula for F. I don't really know, but they'll give you something. And they'll say, what is the absolute max? Is it possible to look at these and say, oh, for sure not that one?
I don't think so.
Tell me why.
Because the graph could be at any point on the Y.
It's perfect. It's perfect. Yeah, this could be the absolute max, for sure. Because you don't know anything about F. How many understood that? 2 points. Well done. Please.
But if it does give you a closed interval, couldn't you rule out negative infinity because it starts and ends at that point?
Oh, I just wrote that with really bad handwriting. Sorry, Mikhail. Like that.
Oh.
okay.
I was like,
Sorry. Didn't mean to cause confusion. So. Very good? Awesome. Cool. Everybody good here? Okay. Now, one thing to keep in mind, Noah, is it took a long time because I'm guiding you through it. It doesn't take very long once you know the concept, know the principles. I mean, it's not like a quick problem, but welcome to life. So, no, I'm not kidding. Like, people don't get that. Maybe some of you do. I don't think everyone understands that. You know, a job that pays $12 an hour pays $12 an hour because it's not hard to find someone to do it. A job that pays $60 an hour pays that because it takes a lot more to do that job. So you want to do simple things, you're $12 an hour. Complex things, you've got to do complex things. Okay, go to number 3. Number 3 in the packet. Okay, something to memorize. Please do not forget this. On number 4, we figured out a way to use a sign chart of F prime to draw a sketch of F. And that works really, really well. It will always work. But only because it indicates simply, as Isaac said, when F goes up and when F goes down. Okay? So that works really, really well. Here, we're trying to figure out when F is concave down. Okay, sketching concavity I find to be difficult. So we actually won't do a sketch on this one. But we can still do the sign chart.
You just do the sign chart, you find it prove it twice.
Nice. Because when F double prime is negative, F is concave down. So we're going to use the exact same method, but instead of making a sign chart of F prime, we'll make a sign chart of F double prime. No graph this time. That'd be good? Awesome. So the steps are the same. We first must find F double prime. So use the quotient rule. So bottom, multiplied by derivative of the top. Subtract the top, multiplied by the derivative of the bottom. All divided by the bottom squared. Question? Did you catch up in your notes? Anyone need me to talk again why we are doing F double prime instead of F prime?
Yeah.
So look at Danica's chart. Remember, when you make a sign chart, you don't have any numbers. All you have are positives, negatives, and 0. So to determine when F is concave down, I need to know when F double prime has negative values.
That's easier to do than increasing and decreasing.
Yes.
Because you don't know if it's, okay.
Yeah, without numbers,
You don't know where
yeah,
it's.
without a graph, you can't tell when something's increasing or decreasing.
So if it's wanting like relative extrema or whatever, then you could do F prime. If it's wanting concavity, then you should do F double.
Very good. Because like right here we were trying to answer, let's do the whole room. This problem we were answering, where does F have an absolute max? But they could have just as easily have said, on what interval is F decreasing? Look at our work, raise your hand if you can answer that question. On what interval is f decreasing? Grant?
From 0 to 2.
How many agree? 2 points. So if I'm, trying to find where f is decreasing, this works great. I can see it. It's perfect. It's the concavity that I can't see.
Yeah.
Does that answer your question?
You don't know where
The concavity is hard to see. Are we good?
but it is easy to see when you can see where you move from positive to negative and where it does switch.
So just kind of to reiterate it, we're finding f double prime so that we can see the positive and negative to see where f prime is increasing and decreasing.
Which will tell us when f is concave up versus concave
Okay,
down.
that makes sense.
That's perfect. 2 for Rachel. Okay, keep going here. Anybody need me to talk more about that? Really, hey, the steps here are easy. It's the big idea that's got to stick. If the big idea sticks, you'll remember the steps. Anybody need more help? Waving? Anybody waving? People waving? No, brave people. Okay, good. So now we do, let's see, that's y prime still. This is 0 minus -5 times 1 all over x minus 2 squared and squared again. Squaring means to multiply by itself. So what I really have on the bottom is x minus 2 to the 4th. Because I have x minus 2 times x minus 2 times x minus 2 times x minus 2. Did I do it 4 times yet? I don't know.
I have no idea.
Times x minus
Why
2.
is it squared?
Because it's this.
Oh, I don't know. Hands up if you know the error. Who sees the mistake? Come on.
Somebody
2 points. It's not supposed to be squared again. That's the next step. That's lame. Just pretend I didn't talk for the last 35 seconds. Back up the video. Skip that part. So y double prime is 5 divided by x minus 2 squared. That was very awkward, sorry. Okay.
Isn't it a good derivative of that for double prime?
Yes. So now we have y prime.
Yeah.
We do it again. New color. 2 for Avery.
Mr. Smith?
Yes, please.
Would you recommend squaring it before, or like, you know what I mean?
Oh, expanding it?
Expanding it before you put it in?
Oh, outstanding question. 2 for Danny. My rule is, based on my experience with the AP test, is I never expand unless I can think of a reason why it will help.
Okay.
So I actually hardly ever will expand.
Okay.
Just leave it. It's usually bad.
So would it be easier when you're taking second derivative just to like drop the square root?
Drop the squared and...
Like when you take the derivative, you put the 2 in front and it's, you know.
Oh, you have to use the power rule, yeah.
Okay.
Yeah, that will work just fine.
Okay.
Yeah, my experience has been, whatever they give me, I almost always just leave it alone and go to work. An exception is if I'm dealing with like ln and e interacting, then I want to do some algebra first.
Okay.
Otherwise, I don't usually find it helpful. There are exceptions, but most of the time it doesn't help. So I never expand unless I have a reason. The other reason I don't really want to expand, Danny, is I know that to use the sign chart, I need to have y double prime factored. Right now, this is factored. If I expand, it's not factored. So I'm going backwards. I'm going in a direction I don't want to go. Like I want to get this thing factored. So. Okay, y double prime is going to be the bottom, multiplied by the derivative of the top. Subtract the top, multiplied by the derivative of the bottom. Now we get the double squaring. Sorry for the early mistake. That parentheses sad. That one's better. Zero minus 5. Now use the power rule. 2 multiplied by the x subtract 2. The new exponent is 2 subtract 1, multiplied by the derivative of the x subtract 2. All divided by x minus 2 to the 4th. Because x minus 2 squared squared does mean what I was saying before. X minus 2 times x minus 2 times x minus 2 times x minus 2. Question? 2 for Allison. Okay. But yeah. Awesome. Keep working. So this is -5, 2, x subtract 2, multiplied by 1. X subtract 2 to the 4th. Questions? Please. Oh, true. How many saw the mistake? 2 points. Okay, something a lot of people have been struggling with is dividing illegally. So please remember, only divide if the top is factored and the bottom is factored and you're dividing factors. And a good way to check to see if you're legal or illegal is just look at equality. This is the same as this. Because if I were to multiply these separate fractions, I get the same result. If you can't write the big fraction as small separate fractions, then you're doing something illegal. This is legal. These divide to make 1. But if you can't rewrite this like this, it's illegal. So stop doing illegal things. Question?
Is that illegal or is that?
This is legal, and here's why, Hayden. Help me. If you take 4 fractions and multiply them, you just take the top. This times this times this times this. Is that the same as this numerator? Perfect. Then you multiply this times this times this times this. Is that this denominator? So it's legal. But I've seen a lot of people, Hayden, try and do stuff like this. And say these divide, but I can't rewrite this thing like this. Like I challenge everyone in the room to come up with a fraction that I can put here and here, and when I multiply, you get this. Like 2 times what the heck is going to be 2x plus 1? Like you can do it, but it's not like usually very convenient. It makes things worse. Boston?
X plus 1/2.
That works. But you're getting now kind of a thing that's usually not as helpful. So if you can write it, then it's legal. But if you can't, so you can't do this. That's illegal. Question? We good to hear? Points for Boston. So I got y double prime now. So y double prime is -10 divided by x minus 2 cubed. Question? Awesome. Time to make the chart. Okay, this may feel a little tedious, but I just want to make sure no one is getting lost in the method. Please.
Isn't it supposed to be x? The bottom is your 4.
So these two divided to make 1.
Oh, okay.
2 points. Okay, I want to make the chart, please. Raise your hand if you know the first step in making the chart. What's the first step, Henry? So draw an x-axis. And for this particular problem, Cambry, what are the, how should I say, like, is there a beginning, what's the beginning and what's the end of my x-axis on this problem? Yeah, checking the problem is smart.
Well, on the last one they gave us like a closed interval, but this one didn't, so how would you?
So they don't give you one, then it's negative infinity, positive infinity. And I won't write those in, we'll just kind of assume that's the case since we didn't put any restrictions. Please.
Would you look at the answers on here and use those to help?
Listen to Danny. You could in this, well, no, not really, because this says whenever x is less than 0, so it could go like forever. So 2 points, 2 for. How many knew we were supposed to draw the axis? Come on, hands. How many knew it? Be honest. Point, 2 for Cambry. What's the next step? Everybody, come on. I gotta make sure everybody knows and understands the method so you can get the homework done. What is the next step? Avery?
Well, if there is a way to factor in, if there's not, you treat it as one.
Well done. Let's say that again.
If there is a way to factor in, if not, you treat it as one.
One big factor. Just one big factor. How many knew that? 2 points. Okay, here you can take the numerator factor and treat it separate from the denominator factor. So I have -10. Let's do a different color there, sorry. So -10, and then the denominator factor is x minus 2 cubed. These two factors will divide, and the result of the division is f double prime. So make sure you write that. Hands up if you know the next step in the process of making a sign chart. Oh, please, Allison, question first.
So, when you were multiplying it, so you just do the same thing whether or not it's multiplying or dividing, like, right?
Mhm.
Okay.
These are dividing, doesn't make any difference as far as the method yet. It will in a minute.
Oh, I was gonna say the next step is find the zeros.
Perfect. So Hadley, of all these different values for x, which one of them, when plugged into this factor, will make this factor equal to 0? None of them. So this factor is always negative. 2 for Hadley. So for any value of x, that's just negative. Anyone have a question on that, please?
Really fast, you see you have that division sign. If I did the derivative or whatever and my equation came out with like that divide, that I just do the factors of division. Then on last time, if I do it and it comes out like two things multiplying, then I put multiply. But what if it comes out with like 5x plus like 12, then do I just put a plus there?
Oh,
Do you know what I mean?
I do. Everybody watch. Hey, everybody watch this question. It's really good. 2 for Brendan. Hey, points for the whole room. We find y double prime to be this, or we find y double. This is what you're asking, right?
Yeah.
We find y double prime to be this.
Or like if it has like sine or cosine in it.
Hold on a minute. You're doing great. Or we find y double prime to be this. Or y double prime to be this. So let's start with the first one. So everyone's going to get points on this. So if this is your y double prime, raise your hand if you know what you should be listing here in your sign chart. Hands up. If this is y double prime, what should you list here? There's more than one correct answer. Let's go, Ellie.
3x and then 10x squared.
So how many vote 3x and then 10x squared? So 2 points, but no. Who knows why you don't do that? Elijah?
Because you need to factor it out if you can.
Never make a sign chart with terms. Never make a sign chart with terms. Two things added, they're terms. So never, that will not work. Here's why. Once you get the sign chart built, like we did here, you're going to combine the sign chart. When you get to here, you're in trouble. If these three things are terms, that means they're adding. What's a negative plus a negative? Say it. No, negative plus a negative. If you're using terms to build a sign chart, here's the problem.
Oh.
What's a negative plus a negative?
Negative.
Fine. What's a negative plus a positive? Louder.
Depends.
Yeah, who knows? So don't ever build a sign chart with terms. Wave if you need me to do that again. Okay, cool. So back here, don't build a sign chart with these two terms. Where'd it go? It's down low. That won't work. You have two other options here. Who knows the other two options? So many hands, come on. Who knows the other two options? Isaac?
You can factor out the x, or you can just use the whole thing.
Perfect. So you can think of this as one large factor that is valid, a little bit harder, or you can factor out an x and get two factors. How many knew it? 2 points. Is that answering your question? So let's go to this one. Hands up. What are you going to put here on your sign chart for this one? Right here. Rachel?
You just for all of it and look at it as one term.
Yeah, not factorable, because the x squared is inside the cosine. So the best you can do is just one big factor. Just one big factor.
Like all red, like
Just-
just 10, like wherever the 10 is.
Yeah, this would just say cosine x squared plus 6x.
Okay, and then do you have to do unit circle when you think about
You're
it?
going to have to use the unit circle.
With like one, like, you know what I mean? Like if I plug in a 2 for that.
Don't worry about the details on this at this
Okay.
point. Just make sure you got the big idea, which is you'd have to do the whole thing. Well, it's a little bit complex for today. So,
Okay.
okay. How many knew it? 2 points. Have I answered your question, Brennan?
Yeah.
Awesome. Oh, what about this one? Hey, hands up. What are you going to list here for this one? Show me your hand. What gets listed for this one? So we'll have it.
Can you put all of the factors?
You do. So what are the factors?
X, X plus 2, X plus 4, X plus 1.
Right. So you list x, x plus 2, x plus 4 squared. These two factors will multiply. That result will be divided. How many knew it? 2 more points. We want me to say it again, just wait.
How do you
Go ahead.
times n multiply?
So on the chart, you'll have 3 rows.
Times n divide.
You'll have 3 rows.
Yeah.
The first 2 rows will multiply. So you'll say, hey, negative times a positive is a negative. That negative divided by the third row is going to give you the final result. You good? 2 points. Please.
Will it matter the order that you multiply and divide in?
No.
Wouldn't you need 4 rows to do that if you had all 3 of them? Because you'd multiply the top 2 and then get a row for their product?
Oh, you
Then-
could.
Okay.
Although I found most people can do that mentally, so they don't really need
Makes
a third
sense.
row. Does that make
Okay,
sense?
yeah.
No, your thinking's perfect. It really is. Just with experience, I've seen, oh no, you can handle it. So.
Okay.
Anybody else? Cool. So let's get rid of that. Raise your hand if you know what I do next. Come on, hands. Who knows what comes next? Come on. What comes next? Lindsay?
Find the 0 for the x minus 2.
Which is what, Lindsay? So what is the 0? You're overthinking it. Let me help you. One of these x's, when placed here, will make this 0. What x is it? 2. So when x is 2, this factor has a value that is 0. How many knew it before she said it? Point. 2 for Lindsay. What's the next step? Hands. Allison?
So then, for when you plug a 0 for x, you'll get a negative.
Good. So I go 0 here. That's definitely negative. Because 0 minus 2 is negative 2. Negative 2 cubed is definitely a negative. We don't care about the numbers. So now we know if we plugged in negative 10, or negative 5, or negative 3, or 1, the result would still be negative. That's the beauty of this method, is one test answers the question for all. They knew it before she said it. Point 2 for Allison. Next person, what's next? Drew?
Find out if it's positive or negative above 0.
So pick a number, Drew.
3.
Perfect. So 3 subtract 2 is 1. 1 cubed. Good. 2 for Drew. Questions? Awesome. So now, don't multiply, divide. Do the zeros first. Say it out loud, please. What's a negative number divided by 0? Undefined. What are you? But what's a negative number divided by a negative number? Positive. So I know that if x is negative 10, the value of f double prime will be some positive number. Same is true for all these. This one's negative. Now I know something about f. F is concave up. F is concave down. I use this method, as I told Danny earlier, when I don't have a calculator and I don't have a graph. Then this is the way to go. Questions? Some teachers will teach this as, they'll teach it as the, if you want to Google this, you'll see other method. Another method is known as the first derivative test and the second derivative test. That's the method I learned at BYU. If I could find the time, I'd be glad to teach you that method as well, but I feel quite confident that you will like this method better. Okay, I've seen both ways. This is easier. So, okay, go to number 42 in the pink. Go to number 42 in the pink. Okay, 42 in the pink really should have been in the yellow. That was a mistake on my part. Because notice, they give you a formula for f double prime. There is no graph. And they want to know when f has points of inflection. So they want to know when f is switching concavity. Okay, so this is a perfect problem for a sign chart. Because if I can make a sign chart of f double prime, I will know when f double prime changes from positive to negative. I'll know when f changes concavity. So we need a sign chart. The nice thing is they gave us f double prime. And f double prime is already factored.
Isn't it just n0 on f double prime?
Oh, no. So let's keep going, you'll see why. Perfect, 2 points. So that's actually a misunderstanding. So don't worry. So first step of the sign chart, hands, come on. First step, hands. First step. Ellie?
Draw an x-axis.
Draw an x-axis. Now in this case, you can think of the x-axis as going from negative infinity to positive, because as Camry said, they don't give us a span. You could use Danny's method on this one though, because it says at what x coordinates are there points of inflection? And the only x coordinates they give you are 0 or higher. So you know you're only looking there. On a written portion of the test, you wouldn't know that, so I think it's actually better to not practice that way. But is that be good to there? Cool. So what's next? Hands up. Come on. What's the next step? Show me your hands. What comes next? Hey.
Like what's the x squared and then x minus 3 and x minus 6?
So the name to memorize is we're listing the factors of f double prime. How many knew it? Point 2 for Hayden. Hands up, what comes next? Come on. What comes next? Anna Kate?
Find the zeros.
Find the zeros. So Anna Kate, what's the 0 of the x squared factor?
0.
What's the 0 of the x minus 3 factor?
3.
Make sure you put some good space here. If you get them too close together, you'll make a mistake. You must have space between the zeros. And the factor here, Anna Kate?
6.
How many knew it? What? We don't want to talk about it. Next step, hands up. What's the next step? Show me your hand. Rebecca?
Find out whether x squared is positive or negative.
So pick a number over here, Rebecca.
3.
So is x squared going to, so if I plug a 3 in here, is the result positive or negative?
Positive.
Positive. How about on the other side, Rebecca?
Positive.
Also positive.
So you do have to check, you can't just.
Yeah, if you guess, you'll make a mistake. They'll
Okay,
trick
just
you.
Negative and positive.
They'll trick you for sure.
Don't you have to write f double prime on the factors?
Oh, how many noticed that? 2 points. Good job, Raquel. Okay, show me your hands if you know what I'm going to write here. Just show me your hands if you know what I'm going to write here. Across, like who knows what I'm going to write here? So what is it, Elijah?
So you're gonna write negative. And then positive.
How many knew it? Point, 2 for Elijah. And like I said to Brendan, do not guess. Do not say, hey, this is what always happens. Always test. Like I've seen so many AP questions where they just were clever, figured out a way to just fool you.
So that you thought.
Always test. So, hands up, who knows what I write here? Show me hands, what gets written here? Can't reach. So a positive, multiplied by a negative, multiplied by another negative, positive. How many knew it? Point, 2 for Cambry. I should have done the 0 first. No division, so nothing's undefined. Here's the answer to Weston's question. Say it out loud, please. How many zeros does f double prime have? Say it out loud. Just say it. 3. How many inflect? Now listen carefully. We are not finding inflection points on f double prime. We did find zeros of f double prime. We're finding inflection points on f. F has an inflection point when the concavity of f changes. How many inflection points does f have? Say it. Here's f. F is concave up, concave up, concave down, concave up. How many times does f change concavity? Say it. 2. 3 zeros on f double prime, but only 2 inflection points on f. You need me to explain more detail. No one's waving, the bell's in the ring. Makes sense?
Yeah.
Good work.
Mr. Smith?